Alright, good afternoon. If you don't hear me, please tell me, I'll take the mic. But otherwise, so Hussein said everything. I'm Ilya, I'm a postdoctoral researcher in the ILPS group here at the University of Amsterdam. And I will continue talking about the same topic as Diane opened. I will talk about user biases from a different perspective. And I will, well, first I have to say this is a joint work with a few people, and in particular with Alexei, Martin, and Pavel. Martin is here in the audience. So first I'll say a few more words about bias in user interactions, just add a little bit of more terms and notions that I will need here in my presentation. So first we talk about search engines, web search for example, and we talk about users that interact with those search engines. They enter queries, they click on results, they scroll through results, they use mouse, they could use touch gestures on mobile devices and so on and so forth. So all of those are different types of interactions, right? And we want to look into those interactions. If we take the example of clicks, that's the most obvious and simple type of interaction. There are already two problems with clicks. First problem is interpretation. It's a little bit related to the last question actually. What does it mean that people click on the result? What does it mean that people click a lot? For example, we can say, well, a click is good because I liked the first result and I clicked it, right? Or I liked the third result and I clicked it again. But it could also mean that, well, I didn't find what I was looking for during the first click, then I clicked the third, maybe I didn't find, and I clicked more and more, so it could mean the opposite actually. So interpretation is a problem, and it's not the focus of my talk. So here I will assume that a click is good. So if a person clicks on a result, then we assume that that result was somehow relevant, interesting to a user. And the second problem is bias, actually. So luckily I don't have to give you examples of bias because Dan gave you quite some examples. Position bias, attractiveness bias, and so on and so forth. Actually, the first result was clicked probably because it was just first. Maybe it was not the best, but it was first, so users just tend to click on the first result. That is it. Now, if we think that clicks are good, they indicate the relevance, let's say. Of course, we want to use that information to improve our search, to evaluate our search, but, well, we know that this click might occur just because it's on the first position, so there is bias. To use that click reliably, we actually need to remove the bias first, and then use some kind of unbiased click to improve our search engines and so on and so forth. So there are two ways of dealing with bias. As Diane told you, well, one way is you try to design systems that help users overcome their biases, help users to broaden their horizon and so on and so forth. For example, the search results navigator. And the other way is if you have a biased interaction data already, well, you want to learn to remove biases and use your clean, unbiased data to improve your search. And that will be the focus of my talk. So you're lucky you'll have the full set of talks about bias in user interactions. Right, talking more about clicks, I'll give you just a very general idea of how people attempted removing the bias from user search interactions. So we have a click, let's say a probability of click, and people try to split it into two components. The first component is about looking at the result, at the snippet, at image, at entity, whatever. And the second component is about actually liking this result. And when we look at the results, the way we look at the results is very biased, right? We look a lot at top results, we look very little at bottom results, we might look at images more than at text results. So the way we look is biased, and we want actually to put all the bias into this component. And the bias may be because of the position, as I said, because of the presence of a visually salient content, because of previous clicks, and so on and so forth. So we want to actually separate the bias into this component, the way we look at results. And what is left, as soon as we looked at the result, we can decide in an unbiased fashion whether we like it or not. So we're already looking at it. Now we are unbiased, kind of, and we will decide whether we like it or not. And this is really the relevance, the quality of the result, right? So what people are doing, they're trying to create two components. One, the one that absorbs all the bias, and the other one that becomes unbiased thin, the unbiased click, let's say in this case. So this is a general idea. It's not that straightforward to do this actually, to come up with the components, to learn the parameters of those components. So a lot of work has been done on that. During the past 8 years, well, many people attempted to do this with clicks, and those models are called click models. Well, if you've been to Honest Defense, you've heard quite some things about click models. And there are so many click models that you can write books about those, and so we did. So we wrote a book about click models, and the first author, Alexander, is also here in the audience. So the point is not to sell our book because there's no marketing here, right, at the meetup. The point is to say that clicks are pretty well studied, and we have to think of other interactions, because people also use their mouse, people scroll, people spend time on search result page, on landing pages, and so on. So we need to go further. We need to go beyond clicks. And that's what we did recently in our very recent work that is yet to be presented at the CGIAR conference this year. So we looked into times between user actions. Because when we interact with search results, we spend our time. We spend our time looking at the results, we spend our time formulating queries, we spend our time deciding whether to click or not, and so on and so forth. There are very many different types of time that we spend. I will focus on just one of them as an example. This time is called dwell time. I'll quickly explain what it is. So you submit a query, let's say Amsterdam, you check the snippet, you like it, you click it, and you start reading the page. And then the time that it takes you to read the page that you clicked is called dwell time. Now this is one of the interactions that you do when you search. And there are again two problems, interpretation and biases. Now interpretation, well, if you read a page that you clicked for a long time, you can say, well, it is a good page because I like it, I read it for a long time, obviously. But on the other hand, you may be struggling finding relevant bits of information in the document, right? You're going through document, you read different paragraphs, and you're not finding the information. So again, two different views, but the conventional view is that longer dwell time is better. So if you spend a lot of time reading the result, it's good. So if you spend a lot of time reading that Wikipedia page of Amsterdam, this is a good page. So we will stick to this. Now the problem with the dwell time is that it is pretty difficult to capture if you are a search engine. Because if let's say I'm running Google or I'm running Yandex, this Russian search engine that we collaborate with, I can clearly capture the click, right? I know that user clicked on the first result, but it's difficult for me to capture the click on the back button so that I go back from the Wikipedia page to the result page, unless I offer my own browser or toolbox for a browser. So what people usually do, they just look into time between clicks. For example, the same situation, a user clicked on the first result, but then he or she clicked on the third result. Now, this time between these two clicks, it consists of dwell time, the time of reading the first one, and the time of getting from here to here. And usually the second part, getting from here to the third result, is pretty small. So the time between clicks usually mainly consists of the dwell time. So it's used as a proxy. So I will consider the time between clicks the rest of my talk. So let's say in this example, a user spent 2 minutes between these two clicks. Most of these 2 minutes, the user was reading the first result, which might mean this is a relatively good result. 2 minutes is a lot, so you spend 2 minutes reading the Wikipedia page, it's probably good. Now let's consider another example. Maybe something changed, maybe personalization happened, so the results were re-ranked in a certain way. Let's say the two first were swapped and the last two were swapped. Now a user came and submitted the same query and actually clicked the same two results. But now a user spent 1 minute, maybe because the first click occurred on the second result and not on the first, and the user was trusting less the search engine and thought, oh, maybe if this result is second, I shouldn't read it for that long. So anyway, we observed something different. We observed 1 minute instead of 2 minutes. So does it mean that the Wikipedia page became less important, less interesting? Well, not really. It's just because the context changed, right? So the results shifted a little bit down. Let's assume the third example. Let's say there was a click on the first result, and the user read the first result, got some interesting information, then clicked on the second, and now he or she already got some information. Maybe she spent only 30 seconds reading the second one. Again, it doesn't mean that the quality of the Wikipedia page becomes even worse. It's just the different context that affects the time, right? So there is bias, and we call it the context bias. So we ran some experiments to confirm that it's not just our intuition, but it's really there. It is there. So we call this a context bias, and we wanted to deal with that bias. Now let's step back a little bit and look at this time. So we've seen 2 minutes, 1 minute, 30 seconds. All those times, they kind of reflect the quality of the first clicked page of this Wikipedia page. How do we aggregate those times, 2 minutes, 1 minute, 30 seconds, to understand how good this Wikipedia page is? Well, there are different approaches. The most straightforward one is just to take the average. Take the average of those 3 times, and that's the, oh sorry, this is the average, right? So this is how much time on average it takes a user to go from this page to the next click. So this is the average time between 2 clicks if the first click was on this page. Well, this is a good model actually. It performs pretty well. It's used as a feature a lot and so on and so forth, but it's pretty limited in its expressive power. It's just one number. There's no model really. So people decided to use probability distributions instead of one number. For example, the gamma distribution. They say that the time to next click starting from this page is distributed as gamma distribution with 2 parameters, k and theta, where the parameters are learned from the past observations. So now we don't directly average these 3, but we put them inside the parameters and the parameters inside the distribution. So obviously there is a problem with these 2 approaches. The no bias is modeled, right? No bias is considered. So we want really to understand what does it mean 30 seconds? What does it mean 120? Is it a lot? Is it little? Why do they differ so much? So one obvious approach to incorporate the context bias would, well, not the bias, but the context, would be to do this. So we have 3 different contexts, 3 different examples, 3 different contexts. What if we model each different context as a different gamma distribution? So we should approximate users a bit better, because we have like a model for each case, let's say. But the problem here is that it's still not clear where the bias is and where the actual unbiased thing is. So we just have 3 different sets of parameters, and we don't know what is affected by bias, what is not affected by the bias. But what we can see from here is that we have, in 3 different cases, we have the same, what we call action. So a user submitted the same query, the user clicked on the same result first, and we want to understand how much time it will take the user to click on the next one. The only different part is context. And again, just similarly to what you've seen in the case of clicks, we want to separate these 2 components. The action, which is context independent, it doesn't matter where this document occurred, it's just a Wikipedia page shown for the query Amsterdam. And we want to separate the context with all its biases. So what we do is we have this model. So we still say that the time to next click is distributed according to gamma distribution. But that gamma distribution has hidden parameters that depend only on the action. So they should be unbiased, but we don't know them. And the context can modify these parameters somehow in a linear fashion. So these linear modifiers, they depend on context, and this blue one is context independent. So we have the context independent part now and the context dependent part now. So we try to separate these 2. Of course, the issue here is how to learn those parameters. I'll skim very briefly over that. So first we do it iteratively. So we fix one type of parameters. Let's say we fix blue parameters, and we optimize red parameters, context dependent, and we fix red parameters, optimize blue parameters, and so on and so forth until convergence. An important thing here, which I'll come back later, is that we use neural networks to learn the context-dependent parameters. This is because we don't really know what causes the context bias. It could be the position, it could be the number of previous clicks, it could be the time of the day, it could be the good weather, I don't know. So we just let neural network learn the sources of bias and learn these context-dependent parameters. And the context-independent parameters could be estimated directly using maximum likelihood estimation or whatever. So it's pretty easy to estimate those, but the context-dependent are maybe difficult. So now we have a model. We know, let's say, we know how to learn it. Now we have a learned model, and of course we want to use it. Right, so I'm switching into evaluation. To do that, we use 3 months of logs from Yandex. So we just logged what, well, not we, the Yandex logged what users were doing. Yandex logged the times between clicks. So we collected over 6 million observations of times between 2 clicks. And we are interested in 2 tasks. The first task is predicting times between clicks. So we've observed some times in the past, let's say 2 minutes, 1 minute, 30 seconds. We trained our model based on the observed times, and now we want to use the trained model to predict new times between clicks. Let's say a user comes, submits a query, clicks on some result, and we want to predict how much time it will take for the user to click on the next one. And the second task is actually improving search, because our final goal in the end, we want to improve search. We want to improve search engines. We want to show better results. And as I said, time between clicks can be a good indicator of quality of results. So we want to use this time to rank results. Now let's look at the first task, which is predicting time. So we have this same situation. We have 2 clicks. We want to predict the time between them. First thing we can do is we can take the average of the observed times, just the same as I showed you, this very simple model. And so the average will be 70 seconds in this case. Another option, we can use the gamma distribution. We can take the expected value of the gamma distribution. Now the expected value of the gamma distribution turns out to be the average, actually. So these 2 are the same. And now we have our own context-aware model. And, well, from here you see it has a few more parameters. So it's more expressive, and we expect it to approximate times better. And that's what we are aiming for. The results, well, to evaluate that, I have to say, we should compare the predicted times here with actual times. Let's say we saw that it took 1 minute in this particular case, so we compare this to the actual 1 minute that the user spent between clicks. And we compare this using 2 metrics, log likelihood and root mean squared error. And we have 2 methods. The first is the average, or the gamma distribution, which are the same. And the second is context-aware model. Yes?
So how did you model the context?
So again, we used a neural network that. Oh, right. Yeah, maybe I got. What is the context? That's a very good question. That's true. So what we pass as an input to the neural net is all the the position of the click result, all the previous clicks that we've observed, positions of those clicks, the average time between clicks during past, I think, 50 searches. So a bit of history, bit of
the content of the other
no,
articles. Because
no.
that, to me, sounds very relevant, because I thought that was kind of missing. Because if you've seen like an overview site that lists all kinds of different options, then your behavior might be very different afterwards. Or if you've seen a very similar article before and then a very similar article afterwards, well, of course you stay there for a lot less, because it's very similar to the one you saw before. So this sort of context might also be very relevant.
True, true. So, well, I have a let's say, two answers. One answer is, yes, you're right, and the content of documents surrounding the first click document is relevant as a context. And, well, a neural network can get anything. You can get just passwords there or something. We didn't do that. We tried to do that for clicks. For us, it didn't work for certain reasons. There were reasons that it
the
didn't
location of the locations, that's what's your context.
So our context was just based on interactions. So previous clicks, previous timings, history of clicks, history of timings, because some users may be slow, some users may be fast. We want all this to go as an input to the neural net. But yes, that was only the interactions, the positions, whether the query is the first in the session, for example. Maybe we start searching for Amsterdam, then we search for Amsterdam hotels, and so on. So that's also the part of the context. So this kind of things.
Is that some sort of a fixed representation you're using for the context here? I'm assuming you would be using some sort of a distributed representation for the context, and that keeps evolving as the session progresses or the context.
Well, yeah, here it's fixed. So for clicks, we use the evolving one. As the user goes down from top result to the bottom result, we change the representation with every new result. But here we just only consider the query and the first click document. And so for them, the representation is fixed. So it doesn't change, so it doesn't evolve. We learn it, for each context, we learn it once and that's it. Yeah, thanks for the questions. I hope they clarify for others as well. Now, all right, so here we try to predict time, and we try to be closer to real users than other models. And here, for example, the lower the, the higher the better, the closer to zero the better. And so we are a little bit closer to zero, right? And here the lower the better. Again, so we are on the positive side. Now the absolute differences might seem small for some of you, but actually they are pretty big compared to what people are trying to achieve. So these are the differences, for example, in the second digit after zero, that people are happy when they have differences in the third digit, for example. So these are pretty high differences, at least in our research. So we can say that the context-aware model can indeed model users better, approximate users better. Now the second task is about ranking results. It's a little bit more difficult. Now a user comes and submits a query, and we just have some set of documents that we want to rank, but we don't know how to do that. What we can do, we can just calculate the average time to next click for each of these documents. What is the average time to next click for this one, then for this one, and for that one. As I told you, the average time to next click is similar to dwell time. Larger dwell time is better, so we just use these numbers to rank these documents. So we rank them, let's say, like this. And then we evaluate the quality of this ranking. We can repeat the same with the gamma distribution, but as I said, the expected value of the gamma distribution is just the average, so the ranking is exactly the same. And now comes our model, and I think this is a very interesting and important part, because in our model we have two parts, the context-independent one and the context-dependent one. Now here, of course, we want to rank documents on the based on the clean information without any bias. So we just drop the context-dependent component at all, because it absorbs all the bias and we just remove it. So we use the clean gamma distribution with, we assume, no bias. So we take this gamma distribution, take its expected value, and that will be the predicted time to next click for each of these documents. And then we rank the documents again. And now the ranking may be different because our gamma distribution with unbiased parameters may produce different numbers compared to the biased gamma distribution. Here I swapped the last two documents just to illustrate that. And now we compare the performance using just standard IR metrics, for example, NDCG at rank 1, NDCG at rank 10. Here the higher the better, ranging from 0 to 1. And you see that the improvements are pretty big. Well, okay, the improvements are around 1%, which what people usually say for a search engine, it's a lot, because if you serve 1 million users, 1% is 10,000 people. If you improve by 1%, you make 10,000 people happier with your results, right? Well, roughly. Yes?
So if it's duplication that come out of the context, how do you measure NDCG in like 2 sentences? What do you measure exactly?
So for NDCG we need relevance labels. we need to know which document is actually relevant or not. And we go from 1 to 10 and sum up relevance multiplied by some discount factor, usually 1 over log of the rank, so that documents towards the bottom of the list get less weight, let's say.
Right.
So essentially you sum up the relevance multiplied by the discount. That's discounted cumulative gain. So that's it. All right, so I hope I convinced you that considering context is important and removing bias is important. But I have to say that apart from looking at the time between clicks, we looked at other times. Time to first click, time to last click, time between queries. All those times are pretty important for search engines. And we observed very similar results. So we approximated all those times better than baselines models. We used those times to rank documents better again. So to summarize, we attempted to remove bias from times between actions, and I think we succeeded. As a result, we predicted users better, we predicted time between actions better, and importantly, we used the context-independent component to rank documents. That was one of the very big goals for us, just to separate the bias from the clean component, unbiased component. Now the takeaway messages. If you have a system and you have users using your system, then their interactions might be biased. I hope that during the last hour we convinced you that it might be the case, and you have to deal with that somehow. You have to understand it and maybe remove the bias. If you want to remove the bias, one of the standard approaches, well, try to think of two components: bias independent or bias independent and bias absorbing components. And then let neural networks learn the sources of bias. So just pass all the input data you can and see what comes out. Well, yeah, that's a black box decision. Alternatively, or in addition to this, you can design tools that help users overcome their biases, as Diane told you. By this, I conclude and show you my unbiased contact details, and I'm ready to take your questions.